Alright, so I'm a little tired, but I have some things that I thought about that I should probably do. It's not so much that I just can't get to bed because I drank way too much coffee. So let's get to it. So hold on, let me get my dashboard open in case somebody messages me. So Twitch dashboard, not Twitch dashboard. What is it called? Yeah, there we go. Just get that open. All right. So, in here, I was thinking that before we even think about the projections of geometry and all the madness that will come from doing kind of simple Boolean operations with this kind of stuff, we should really consider some type of literal subtile map or a 3D tile value, right? So like a completely fleshed out three-dimensional tile. So this so we have like sub, we have add. We're gonna have to know what the dimensions of these are when we use them. Let's since everything here is 8 by 8, why don't we just kind of continue with 8 by 8? And let's make another entry here. So let's take this and paste it, and let's call this, we'll take this as number 3, and we'll call this literal. So for literal geometry, or so we have subtractive, additive, and lit for literal, or we could just call it for geo for literal geometry. And then for this, we'll make it 8 by 8 by 8, right? And that might be a little bit more than we need. I don't know. But that does actually seem like quite a lot. Actually, let's do 3 by 3 by 3, because I just don't want to... Let's try to keep it simpler rather than get out of hand. And for this, these types, right? We have these different types of geometry here. We'll say define SDF profile, and we'll just do geo. So this will be 909, and that's literal geometry. So we have subtractive, additive, and literal geometry, right? And we can make literal. We can make a note there that means literal. I don't know if that'll help or not. It still might be kind of obscure. Okay, so with that, and as literal geometry in a 3 by 3 by 3, we can kind of hack into this and just kind of like get a little 3 by 3 going, right? And no comma on the last one, so no comma last. And with that, let's just add, let's make the, let's make like a 3-dimensional plus. So in this cross section, we go like this. And then over here, we go up like that, and then down like that, right? So now we got this, like, 3-dimensional cross. Or like a jacks, like if you've played, like, that game at the bouncy ball where you grab the jacks. Probably no one plays that. So this is 3, and this is, right, so this is tile 1. Actually, this is tile 0, this is tile 1, and then this last one is 3. So 0, 1, and 2. Sorry, so 0, 1, and 2. And now that we have that kind of stubbed in, we need to put it into the switch statement that we have. It's not really a switch statement, but you see that it is, functionally it is a switch statement. U32.3 equals the tile value. And for that, we'll do SDF, and we'll do the, okay. And then else, we still have that error case for the last case. Else, and that's not right. Else, yeah, okay, that's correct. And for this, we still need to do the logic, so, but we can probably figure out this logic a little bit easier. To do logic. Okay. And we can, you know. Okay, and so profile might not be correct for these names, because this profile isn't really profile, it's like literal geometry. But we gotta just go with whatever. We gotta maintain consistency first of all, and then we can worry about the specifics of finding better names later. All right, let's let me move this around here for a second. I guess that'll have to do. So that's compiling, and we need to think about how are we going to figure out when are we actually going to call this, first of all. So let's tile value and pix d3d converted to uint 32-bit. Okay, so we actually need some type of marching code, and it needs to be so it's actually some type of marching code in here. And we kind of keep on marching and doing this stuff here until we're like, oh, we're outside, right? So, we'll say, interior something like that. So this is like a interior voxel marching loop, kind of goes in here somewhere. And I don't know exactly what the hell it's gonna be, but I know that some type of loop needs to be in here. And we have the XYZ and the Ray World normal. So, and we also have the tile that we're on. So we have all that information. So let's clear all of our bookmarks. So let's go Control Alt Shift and F2 and clear all the bookmarks. I have a clean slate, and let's start bookmarking some stuff. So this function here, and something about having like a ray marching loop here. So the first thought is that with that epsilon x value that we had in the code earlier, this code here is kind of is kind of what we need for... We kind of just need to be able to use this kind of code, and almost, I feel like we should be able to find some type of more generic solution here. Because we're going to take the XYZ and the array world normal, and we are going to march until we either hit a voxel pixel, or we're going to either going to march until we hit a voxel pixel, or until we exit the voxel and have to march into the next voxel, right? And so some of this code is going to be relevant for that. So I'm also thinking that if we look at the structure of this, right, it should be the exact same code, but instead of saying get vox, use XYZ and array world normal, maybe it should be get pix 000, right? And we have a pixel structure that contains the pixel information within the voxel, right? Because this is the exterior voxel information. Maybe we should have something that is similar in detail, but is specifically for pixels. And then we kind of have to do this math, but instead of tx, ty, tz, we kind of take all this math and we use pixel values instead of tx, ty, tz. So we can probably do like a transcription of this, right? So if we think about that, let's think about where this is called. And this is called like right here. And we have this cluster fucky kind of thing here, and then we have the SDF march into voxel, right? So so it almost seems like maybe it almost seems like maybe what we should do is oh, this is like a Voxmar object. Okay, yeah, so this Voxmar object, I think this thing that's called Voxmar, actually, now that I'm kind of seeing the code and kind of the analogies here, I think that Voxmar should actually be called, to be consistent with, let's not match the case. Let's actually see what the struct looks like. So I think that this should actually be called, we have, I don't think this should be called Voxmar. I think this should be called, Pix 000. So we got this Vox 00 thing, and it does have, like, a pixel X, pixel Y, pixel Z. So maybe we're kind of, like, ill-founded here, trying to, like, create this pixel structure. But the thought is that once we're marching inside of the voxel, we no longer... the entire space we're dealing with is that one voxel, and we want like a struct that makes more sense for that. So I'm thinking that Voxmar should be renamed to analogous name as this Vox here. So so voxel current, we could have a pixel current information, and we could have, like, make all of this completely analogous, right? And that, by identifying that those analogous parts, it's going to be easier to wrap our head around this, right? So, first of all, let's make sure that none of the changes we did broke anything before we before we kind of try this kind of refactor, right? There's no such thing as a trivial refactor here. So let's make sure that works. And if that works, we're gonna just start renaming Voxmar. First, we're gonna we're gonna change the capital version. So we're gonna make sure we match case. And any place we see Voxmar, what we really want is it's going to be pix000, right? It's the pixel struct. And let's just find it. So so in that sense, maybe this Vox object should actually be like called tile, but whatever. Let's not worry too much about that. One step at a time, right? Okay, so so let's replace, and where are we? Voxmar about. Oh. Placed. Because we need to do the analogous of what we did when marching into voxel space using vox00. Just this time marching into pixel space and filling. Okay. Control C. Okay, so let's keep on looking for instances of Voxmar. So this we can replace. See Voxmar about. Sure, I guess we can keep the antiquated Voxmar about. That's fine. Sure, whatever. I'm not too worried about the comment mentioning Voxmar. Knowing that's what we called it previously might be helpful. And the next thing we're going to do is we're going to look for Voxmar all lowercase, which is going to be the instance name, and we're going to place it with pix000, which is the struct for the is the struct. So we're going to replace that, replace that, replace that, replace that. Okay, so we did a little refactor there. And now let's make sure that we didn't screw anything up, because there's no such thing as a trivial refactor here. And that's good. Okay. So now the next part is let's looking at this SDF march into Voxel. This is a horrible name because it does not make obvious the analogy here, because really what we need is something like get pix000, use xyz ray world normal, and something else. So let's think about, well, what else do we need, right? And what else we need should be obvious if we look at what we've already have in the march into voxel function. So we've taken the entire vox object, but we probably don't need the entire vox object. It looks like we need the voxel value and the pixel 3-dimensional index, right? And that's probably all we need, right? Because we want to we do want to know what voxel we're in, because that could change the topology of the interior of the current voxel of the current it could change the topology of the interior of the voxel. That's kind of weird to say, the topology of the interior of the voxel, but that's what I mean. So we do want the voxel value. We also do definitely need this. Like, the stuff we've already taken, we definitely need. Alternatively, instead of taking the voxel value, we could take the... we could take the actual location, and that would the actual location in the we could take the actual location of this voxel, right? Instead of getting the value, we could get the one-dimensional index, right? We already have the pixels location, so it might make sense to grab the voxel's location. And the reason why we might want the voxel's location is because if we're going to try any type of auto-tiling, there's probably a point in time where the pixels of one voxel may need to correctly auto-tile with the pixels of another voxel. And so getting the exact location of the voxel that you are in, right, and not discarding that information could be valuable to figuring out how that would work, right? So with that in mind, we should still think about, well, what information do we have here, and what should we kind of discard? So, if we, we're assuming that if we're marching into a voxel, right? We're assuming that if we're marching into a voxel, that that the has is always true. And all this information is derived, so I'm just thinking that maybe we could keep it as simple as possible and just take the tile 3D value and the pixel 3D value, and just roll with that and not even look at the tile value, right? Because we can derive the tile value from the math inside of the function call. So tile, yeah, so let's so let's look at this. So we're saying that instead of taking Vox, we could take the pixel D3D and the actual tile location. And the reason why that would be better is because if we want to implement some auto tiling later, it's going to be a lot easier if this tile value right here is when we're marching into this voxel, is kind of derived, can be derived in here, because maybe we want to compute some auto tiling kind of on the fly. That's my thought there. So I think that we should rename this to something like get pix 000 use, and then xyz rwn, and then yeah, that makes sense. So it's nested a little bit deeper, and so we're going to tack on the new, so this function are going to be similar to each other in design, and we're going to tack on the pixel D3D and the tile D3D, right? So the tile location and the pixel location. So we're going to do tile D3D and pix D3D. So that is I'd say that is looking at that, you might look at that and be like, what the fucking hell? And I wouldn't blame you for being that way if you had looked at this and been like, is that a better function name? But I'm gonna commit to that because I think I know what I'm doing. And so what we can do is we can rename this, right? We can make a note of what it was previously called if we want to, and say that you know, it is SDF March into Voxel. Like if we wanted to keep track of that previous name, we could just throw it in there like that, right? And then we'll go over here, down here, and we'll do the same thing. And so now it's like we got this double thick border, but you know, whatever, let's just do it. That'll keep track of, now we have like two little names. Is that a good idea? I don't know. So we're saying instead of taking Vox, that we want it to have kind of the same beginning signature as the get Vox, but it's going to so we can put pix right up there like that, and we can line everything up nicely. So XYZ RWN, and then the tile D3D is a I32 and 32 because it could go negative. Tile D3D, and then the pixel index is also a in 32, so pix D3D. So the reason why we did it in this order here is because tile is more generic than pixel, right? And we're going from general to specific, so I would say that the point in space is pretty general. The direction is also very general. You could argue that these are both the same level of generality, but remember that when we do point normal form, we think of point then normal. So this seems like the intuitive ordering. Also, to have a direction without an associated point makes less sense to me than having a point that's just doesn't have an associated direction, right? So a lone point is kind of more sensible piece of data than just a lone direction, right? Especially when we're thinking of geometry. Now, maybe I'm completely full of shit, and that's wrong. I don't know. But this is kind of how I'm seeing it, and you'll notice that, you know, this is kind of this might be kind of weird for if you're looking at this and you're like, what the hell? What's up with this code that's kind of like, right, we got this kind of like thing going on here, right? The thing is, everything lines up, right? And I know I can read the function name and I know exactly what's going on, right? So we're getting this pixel struct object, right? We're populating this pixel struct, and we are using XYZ, RWN, the tile D3D, and the pix D3D. So the only thing that's really confusing is realizing that this tile D3D is one variable, and this is also one variable, while this is these are single variables, right? So that is a little bit confusing, and maybe that's a bad design, but let's just kind of keep this kind of like exposed wires kind of mentality as we kind of like figure this out, right? So the next thing is that we got a problem where this is we're already limited in our space, and now we've made this like gigantic function name, right? So that is a fucking problem. So what are we gonna do there? All right, so I would like to just figure out how to like make this condensed. what we could do is, since we have this, we could just make SDF march into voxel. We could make a shorthand. You know what? We'll say fuck that. Let's just call it get pics, right? And with get pics, we will go all the way up here, and we'll just say define get pics, and it's gonna be this guy, and or maybe not, because that is still like way too verbose. So we could call it pics, right? Yeah, I'm just gonna call it pics. That's fine, whatever. All the way down here, we'll just undef, and actually, whoa, hold on. Let's not do that. Let's actually do it in the order that it was defined. So let's just take all of this, and let's go all the way down, and let's just paste it right there, okay? That way, if we accidentally forgot any other things, it'll be all refreshed, and it'll be okay. So pics, is pics used anywhere else in this function? You know, because we made this define that kind of covers the whole function. Make sure that that isn't anywhere else, and it doesn't look like it is. So that's good. And from here, we can, we got to know that this is a function, and that this is a struct, right? So that is going to be kind of confusing. So in our marching code, where we're actually calling this function, right? Yeah, this part is kind of a disaster. It's like nested way too deeply. And I'm looking at everything, and I'm like, what is this, right? So if we could, let's think about why we are nested so deep and what we could do about this. I mean, we could get rid of indentation there. Yeah, we kind of excessively indented, and now we're kind of paying for it here. Here, what I'm gonna do, because this is ugly anyways, let's just try to define pics. So we're gonna define it again, right? So we have it defined way up here. We're going to redefine it as the same exact thing, and that should not be a problem. I don't think redefinition with the exact same definition is not a problem. And we're just going to, you know what, I'm just gonna, you know, this is hacky, but I'm just trying to, like, create some type of region in the code where I can, like, kind of, like, create this region where I have some space to kind of work with. And this is just horrible. This is horrible, horrible, horrible. But let's just get it to work, right? So I'm just thinking we just re-indent, right? We're gonna have a new lease on life with our indentation right here, because it's, yeah, I mean, that's kind of ugly, but yeah, we need to make use of our space, and right now, the more indented we are, we're wasting a lot of space here. So we're gonna unindent and it looks horrible, but we're just gonna do it, okay? And with this, we're going to, we know that that it is this function here, but if we're gonna unindent like that, then why not just call it, right? Why not just, you know, right? If we're gonna unindent it, why not just, you know, so let's sure, whatever. We're just gonna get very unconventional with our indentation here. And, XYZ, RWN, tile D3D, and pix D3D, right? And, where are these guys? Are these, do we have, defs for these, or, so we still need, like, a define for those if we're gonna use them like that. And as far as I'm concerned, we can just, let's not be shy about this. Let's just throw it in there. Let's just go define, and we'll just take that, right? We'll just take this as an alias, a shorthand alias, and then same thing with pix d3d, and pix d3d. Hold on, will that be a problem? Because we have this right here. Is that going to be, is this gonna end up recursive, where it's gonna be like this, and this token's gonna get replaced? Ooh, I think that is. So that's a good reason for why we should have this in uppercase. And yeah, so we should probably have it in uppercase like that, and then we won't have to have that problem, right? Okay, yeah, so that's God, that's ugly right there. Let's put this one all the way at the bottom. So let's put this one all the way at the bottom, and then let's figure out how, let's align this a little bit better. And now let's take all of these and undefine them at the bottom. So down at the bottom here, way at the bottom, let's just make some space here, because I don't know what's going on here. And let's just Control V, and then we'll just say undef, and 2 spaces to make it aligned with the code at the top. And now we have this tile D3D and pix D3D, and we can go over to where we use those, but we can just take this and go TU CMD to make these the defines, so TU CMD, right? So we have the tile dex 3D and the pix dex 3D. So now we have all the information, right? And when we're looking at the code, we don't have to worry like, oh, is this being passed in the correct order? No, we don't have to worry about that, because we see the function name and these variable names line up exactly with the function naming. So we don't even have to look at that and think that, oh god, it's wrong, right? We just look at that and we already know it's correct, right? So now we have to think about, well, we've changed the signature, and this Vox thing, we need the actual, we need to get that value again, right? So we need to actually consult the tile map now and extract that value by kind of like going through the Ugh. So, yeah, I'm kind of tired. So, let's do, this is a, U32, and we'll call it, Voxel. And, same as vox00.voc.val. Okay, so just to note that this is kind of what we're calculating here, and then as far as the pixel D3D right here, we're going to actually throw that value in, right? We kind of take it out of the voxel construct, and we just throw it in here. So pix D3D is already a thing here, and we might want to make a note here, like maybe we want to do it like this, where we go U32 pix D3D, and same as, and we'll say vox000.voc.pix D3D, right? Or AKA, right? So, so these values can also be found in the Vox object, but we're going to like refetch them, just because I think that would be a better way to go about this, especially if we want to implement auto tiling kind of stuff later. So with that said, that looks good. We actually don't even need this anymore, like pix D3D, it's already calculated, right? So we can comment that one out, and this tile value, it's like, I guess we should keep kind of like consistent naming. Like if we call this voxel current, should we call it tile? We should call it tile value then, I guess. I guess we should just call it tile value. So tile value. Yeah, when in doubt, let's try to keep that 2D analogy. And let's just comment that out. And so over here, we need to get current lookup current tile value. So I'm saying relookup because we already had it, but now we are deciding to kind of strip everything down and start over again, right? Because that voxel struct was getting a little bit bloated, and so I think it'd be better just to strip everything down, take only the exact things we need, and then derive some of the information we already calculated again. So that's maybe that is an ill-founded way to do it, but that's the way we're going to do it. So so look up current tile value. So in order to look up the current tile value, we need to do tx, ty, tz to d3d is kind of what we need to do, right? And that's not a shortcut yet. Tx, ty, tz to d3d, and txyz to d3d, and txyz to d3d. I bet that one is, though. Yeah, that one is. So tile xyz to d3d. Tile xyz to index, right? Or tile xyz to index. Tile xyz to dex. Okay, so just some synonyms here, and you know, we gotta figure out what goes here. So let's just put some gibberish there, and let's go back to making this some synonyms. So we're gonna go paste a whole bunch of synonyms, and then we already know kind of what we need. We know the answer is, like, we already, like, made the shortcuts for this a while ago, right? So it's not this one, but it's the inverted one. So, where are you? You are, XYZ to, D3D, this one. So let's take that one, and let's just go back over here, and we'll say, use, and then we can date it with maybe the time as well. So 2020 12:01, and the time is 06:43 a.m., right? Okay, so now that we have that, we'll paste that there, and we'll actually try to use the shortcut that we created earlier and see if it saves our ass. So if we copy it to the clipboard and press comma twice, it'll paste it for us. And we can see, like, the key tx, ty, tz, so this is our tile coordinate. And that's not what we want, is it? Because we want to figure out how to get the voxel value. Oh, right, so we don't even need that. That's great, that's great. So for looking up the current tile value, because we have the index, we don't have to. So all of our tile data is in a one-dimensional array, right? Even though we're storing, even though conceptually our tile map is three-dimensional, the array is just one-dimensional, right? Because all memory is just like a contiguous strip of values, right? We abstract it to have more than one dimension, but everything is just a strip of one-dimensional memory. There's really no all the spatial abstractions. That's all lost. So let's we can use that to our advantage, though. That means we actually we don't have to do as much work as we thought. So so this is almost like a handle to the tile value, except it's a little bit better because with that one level of indirection, we can also get access to the neighboring tiles if we need to derive them later, and we may need to do that. So with that, I know that the tile value is going to be equal to the vat, which is our big thing of voxels, and we're going to do tile d3d, and then boom, that's what we got it. There, we're done, right? So we already have this location and tile value and pix d3d to u30. Okay, so now the question is, should we even be... Yeah, once we get this... So I think at this level is where we would do any auto tiling at the voxel level, I believe. All right, because we're about to kind of like look into auto tiling at the voxel level would go somewhere before this lookup to alt We'd go somewhere. We'd go here and replace this simple lookup. Okay, so I'm pretty sure that if we were trying to do some type of auto tiling, then I'm pretty sure it would go right here, and we would if we were trying to do auto tiling, the logic would go right here, and instead of having this simple lookup, we would look at the tile value, and we would interpret the tile value as a tile set index, like an auto tile index, and then we would interpret tile values based on auto tiling that tile set, right? But for now, we're not going to do that. We're just going to keep it like this. So, so tile value and the pixel 3D. So does that make sense, though? So once we're inside the tile, yeah, so once we're inside the tile, I feel like this might make more sense to still be the tile index, honestly. And the reason I think that is because if we want the most in-depth auto tiling, where the auto tiling can happen at multiple levels, we are going to need to if we want the auto tiling to, let's say we want these pixels here to be able to logically auto tile with the pixels of an adjacent tile, right? If we want that kind of serious logic, where we have nested auto tiling, then we can't afford to lose the the location information of that tile just yet. So let's look at this. And so what I'm saying is that that this might do something, but so I'm gonna make a note here. So wrong. We'll just do not and yes. So I'm saying it should be tile D3D and pix D3D converted to U32 bit. C I don't even know. Um, that's kind of verbose, but you know what? I think that is really the phrase we need for this. So let's take that and let's make some documentation for what the hell is our thought process here. And so let's take that, let's paste it, let's put that over there, let's take this. Okay. Okay, and so why is it that we're not going to do this, but we're going to do this, right? Hashtag cache in indexes at last moment. Why? Because we cannot afford to discard location information at any level of nesting if we want the so basically, if we want any type of nested auto-tiling or fractal auto-tiling, we are going to have to preserve the indexes at the different layers of information, all the way down to the rendering, to where we're finally rendering and calculating the geometry. So it's kind of like a, it's almost like a stack unwinding, maybe that's the analogy, but we definitely need that information. We can't resolve that information until we're all the way at the very core, if we really want to get the most out of writing any type of auto tiling. And for example, if we want a pixel within a voxel to intelligently auto tile outside of its voxel with a pixel of an adjacent voxel, we need both tile D3D, pix D3D, and okay, so we have a little example of why that is, and we could try to make a diagram if we wanted. Might as well, because I'm kind of tired, and maybe a diagram would be nice. So if this is a, let's say we have like a 3x3 voxel. Okay, so we'll say 3x3 voxel. And we're out of room here. We could make the diagram bigger. That'd be one way to solve the problem. Let's just do that. So let's expand that a bit. And 1, 2, 1, 2, 1, 2. Okay, now we got enough room. All right. Okay, so 3x3 voxel. And another 3x3 voxel, right? And current next voxel, right? So we have like the current voxel, and we have the current voxel, we have the next voxel. They're both 3x3 voxels, right? And if we have a pixel inside of here, right? If we want this pixel to logically auto-tile with the voxel in here, well, guess what? If we want that to happen, right? If we want this pixel to auto-tile with this, then so we're saying that all of the pixels themselves can be thought of as auto-tiles within the voxel, right? And so we could think of this voxel here as a auto-tile map, and we could think of this voxel as an auto-tile map. Well, if we want to have the voxel, if we want the pixels within here to not only auto-tile with themselves, but neighboring pixels and other voxels, then it's obvious that we need the index of this as well as the index of this. So that way, if we know the index of this pixel and we know the index of this voxel, then we can derive the index of the next voxel and the index of this pixel here, right? And if we just have this voxel's if we just have this voxel's value, and we have this guy's index location, so we have the pixel's index location, but we only have the voxel's value, then we could correctly auto-tile this pixel within its own voxel. But once we try to get it to auto-tile with something, another pixel outside of its own voxel, then we're in trouble. Then it's yeah, we're screw it. No, there's no way we're doing that, right? So yeah. So if we wanna do that nested auto-tiling, we're gonna have to do it like this, right? So let's make one more thing here. So I think it's going to be easier to understand if we have like A, B, C, and D. And A, B, C, D. A, B, C, D. Okay. Maybe not the best way to do this, but whatever. Let's have some fun. So we don't have to be too serious about this. Okay. So, A and B can auto-tile with each other by just knowing what voxel inside of. Okay, so voxel value may determine. Okay. A and B can auto-tile with each other by just knowing what tile versus... C and D. So it's the same thing with C and D. Let's just take the same. Let's just cut and paste here, right? So C and D. It's not like we're already used a lot of space. Let's not worry about that. So A and B can auto-tile with each other. So A and B can auto-tile with each other by just knowing what tile value / voxel value they are inside of. C and D. Hold on. Let me check to make sure. Yeah. Okay. So, C and D can auto-tile with each other by just knowing what tile value / vox val they are inside of, right? So it's the same phrase for both these A and B and C and D, respectively. They both can tile with each other because they are inside of the same voxel, and they know the voxel value, and the voxel value could determine the properties of the pixels and how the pixels auto-tile, right? Now, if we want to cross this boundary, though, well, this voxel value could actually determine what type of material this is, right? And this voxel value could determine what type of material this is. So, if we only have the voxel value here, then there's no way to get the voxel value here, right? So that means that we could know where this is, because we already know where this is because we have the pixel location, and we can derive this pixel location, but there's no way to figure out what type of material this pixel has, right? And without knowing what type of material this pixel has, we can't decide if these two things have the same material and should fuse together. Okay, so B and C cannot auto-tile with each other with only reason. And so let's go over the reason for why B and C cannot auto-tile with each other. Reason, tile value can determine the material properties of the pixels contained within it. If we only have tile val and pix d3d, we can figure out C's location by using B's location, but we cannot figure out C's material type. Without knowing C's material type, without knowing C's material type, we cannot know if B and C should fuse with each other due to using identical auto-tile sets. Okay? So that is kind of like why we need to make sure that we're kind of passing around the D3D values and not the final values, right? We're gonna resolve the tile values like at the last possible second, so that we can get the maximum utility and the maximum utility or the maximum sophistication out of some type of auto tiling mechanics. And you know, auto tiling isn't you've probably never heard. Well, I know that there's some auto tiling voxel engines, but the idea is that we could probably get auto tiling to work at multiple levels of detail, and that could really help us paint some interesting structures with a minimum amount of effort. So that's what we're gonna do. So it's gonna take a while to figure that out, and hopefully we don't like lose this note and totally forget about this. But we are gonna try our best to document why we're doing what we're doing, and hopefully that will be our savior, right? Okay, so let's look at this. So not this, but that, right? So let's take this and let's go look for the not thing, and we'll replace it with the thing we should replace it with, but we're going to do it one at a time, just to make sure we're not replacing anything in the comments. So instead of tile value and pix d3d, we're going to do tile d3d and pix d3d, converted to a U32 bit. And That bit could be any type of information we want. For now, we're just kind of sticking with like 0 and 1, but we could encode a lot of different types of information with that. So let's replace that, and we're going to keep that. Find next. And this is where we call it. So let's replace that. And so now it's just this not. So we're good there. So let's go to where these functions are called. And we know that we actually have to like change the what we're doing here, what we're calling things with. So we have the tile D3D is actually already passed in, so we're just gonna take this will just be tile D3D, and then over here this is going to be, and actually let's save some space here. Let's just do tile D3D, comma pix D3D. And let's just we don't need that, right? Let's just put that over there, right? And another comma. Okay, so tile D3D and pix D3D converted to a U32 bit. Okay, that's good for me. So now let's look at this code and make sure that we changed the names of the parameters, because we probably didn't. Okay, so we need to change that. So let's kind of move this around, and so we're gonna call this tile D3D, and then this is pix D3D, right? And actually we could probably just do this, right? Since we have that and there, we could we have enough room to put the type before it, right? So we can kind of write it like that. So tile D3D and pix D3D, kind of cluttered, kind of ugly, but I like things to line up when I can get them to line up, so that looks good enough for me. Let's look at this tile value decision here, right? So we have this kind of switch statement based on the tile value, and there's no auto tiling kind of going on yet, but because we want to just figure out how to get some interior kind of like geometry going here. So for that, we're just going to we do need to derive the tile value now, though. So we can actually go U32 tile value, and what's up with this? What is this? D3D, tile X, tile Y, tile Z. So we have this stuff, and it's like, we don't really need this stuff yet. We could comment this out and maybe just keep this for reference, because we're probably going to eventually need this kind of stuff at some point in time. And this might be where we need it, but we don't need it right now. So we're going to comment that out. And U32 tile value equals the VAT with the tile D3D value, right? And that's going to give us the tile value, right? We just look up the tile value using the dex3D value, right? So let's trace back these values, the D3D and the tile 3D, and let's just make sure that as we've refactored, that things haven't been renamed, and that we're actually using the pieces of data that we think we're using, right? So D3D and pix3D are right here, and where are they coming from? So let's color code these two different colors, and let's kind of scroll up and see where that is in this function. So it looks like they are passed directly in, so without any renaming or anything, so that's good. So let's go to where this function is being called, and this is our kind of like our clusterfucky problem child here. So in here we see that we're passing it down again, but we're using these kind of color-coded functions. So let's actually tile tile D3D, pix D3D. We'll just color code those the same color because they are defines. And let's make sure that as we scroll up, the defines, they make sense, right? So the define is vox00.voc, and the exact same name. The names match right here. So that's good. Now the other thing as well is voc populated by the time we get there. And it looks like, yeah, vox is populated right here inside of this loop. This loop runs at least once, so we're going to get that. And then, oh, wait, so this is actually inside that loop, is it not? Yes, it is. It is inside this loop. That makes sense because we, when we're getting the distance to the next voxel, right, we're not just ray marching, we're also ray casting. Like, the math wasn't too hard to figure out how to get directly to the next voxel. So every time and we can probably get rid of this normalize right here. I don't think we need that. And it also says temp debug. Let's not worry about that right now. That's more of a cleanup issue for later. So yeah, every time we run this, we should end up in another voxel because we get the distance to the next voxel. We get the distance to the next voxel, disnext, and well, actually, disnext starts out at 0, but that's okay because we need to figure out where we started at and do stuff based on that. So that's fine. However, does that compromise the fetching information? No, it doesn't, so we're getting the voxel stuff right here. Okay, so that's good. So that means that these values should be populated by then, and we're good. So, well, we're pretty sure we already have pixel D3D and tile D3D, because we can see in the code right here, right, that we're kind of color coding based on what interior pixel we have, and we also have some color coding based on what voxel we're in. So I see no reason to disbelieve that tile D3D and pix D3D are indeed the correct values. So with that, I think we have like a decent refactor in progress. We haven't really added any extra functionality. We've just kind of thought about, hey, hold on, what is the actual data we need? Which data? How far does certain data need to be carried? And if we want to get some type of nested auto tiling, we're gonna have to nest. If we want nested auto tiling, we kind of need to be able to. The deepest level of nesting needs to be able to access the outermost layer of nesting. So the deepest layer of nesting needs to have all of the information at its fingertips to know exactly where it is in the nesting hierarchy, right? If you want the most sophisticated auto tiling that can compound at different levels, that can nest, then the deepest nested element within this structure we're building needs to have the correct pieces of data so that it can traverse all the way outside of the hierarchy and then dive into adjacent hierarchies so that it can compute how it should blend with adjacent elements, right? So with that said, let's I don't know, let's change the formatting here. Let's just put like a little right there. Then that's just there to keep the indentation correct when we do when we do this, right? We don't have to worry about the indentation collapsing if we put that little comment character like that. let's take a look at this and see what kind of mistakes we made. And I'm hoping they're just syntax errors and we didn't like accidentally break anything. And I don't think so, because we haven't really been adding extra functionality. We've just kind of been stubbing stuff in. So let's just take a look, figure out what's going on. So we have a syntax error on 1058. So let's go to 1058. 1058. Now let's think that the most insidious syntax error can be caused by a define. Just keeping that in mind as we do this. And that's not the case. It's just that we have a lax comma, and this is not Golang. We can't do that. So, or I think lax leading comma doesn't even work in Golang. A lax comma on this side works, but lax commas on the left-hand side actually don't work in Golang. I know, because once I started to develop this kind of style, all of a sudden I started to hate Golang because of how they force a certain style. Like, I really like Golang, except for the fact that they enforce a certain style of programming and formatting your code. And it's not compatible with my rigid column limit. The column limit is pretty high up there on my hierarchy, and with Golang, they can make a lot of that very difficult with the way they enforce formatting. And then I learned that Golang was just a modern version of C, and then I was like, you know what? I'm gonna learn C. And then I'm like, you know what? I like C. Let's just stick with C. And not have so many weird fancy tools. Oh, so Git is unexpected token. So let's look at that. So 2117, Control Z, 2117 and 7. 2117, and oh yeah. So when we cut and pasted, this was kind of like an ugly mess, and yeah, that is why. So take that. And we'll paste that, and we're just going to try to get this working. And we haven't really added any extra code. We've just kind of refactored and moved things around. But I think assign, god damn it, where the hell did you go? Assign cannot convert from const medium p float to high p you went. Okay. So, and that's 1101, so Control G, and we're going to go 1101. U32-bit is a uint32, and takes tile D3D and picks D3D, and these both should be, I know we changed the signature of this. We changed the variable names. We might have not correctly changed the types, so both of these values should be signed integers because they're locations and they could possibly go negative. So let's take a look at this function. I'm going to guess that we forgot to change the signature here. Yeah, so this tile 3D needs to be converted to an int 32. And with that, let's see if maybe we can get ourselves out of this mess finally. Okay, so we're finally out of this mess. So let's hope to our non-existent god that the code up here is still in one piece, and it looks like it is. So that's awesome. So so we've kind of like thought more about how we want this to work. I am still tired, but I just wanted to take some time to do the next steps that I was thinking of while I couldn't get to sleep, and get that out of the way, organize my thoughts that I have, because when you're coding, really all coding is like, okay, what's the next step, right? And then you just code the next step, and then once you've done that, you go, okay, what's the next step after that? You code it, right? You know, most of the time you'll probably be okay if you just think one step ahead at a time, right? And just focus on the current task, and then focus on the next task, and just do them as they come by, right? So what's next? So let's go look up at our settings here and see. Not camera settings, projection settings. So this kind of stuff here, right? So SDF Pro Max actually needs to be 3 now, because there's 3 pieces of geometry we're kind of working with. And let's go look where that value is referenced. So we have 1, 2, and 3, right? And these are the different data sets that we're going to use to render the voxel, depending on which one is selected here, right? So with that, before we even figure that out, we have to figure out just the basic voxel marching, do we not? Or is this part of the... Or, I guess this is kind of the part of the marching process, right? Because we need to... so, interior voxel marching loop. Yeah, that makes sense, because we need to march to the... so really, this is pixel marching, right? Instead of voxel marching, this is marching to the next pixel, right? So we already did the voxel marching earlier, and now we're just nested 1 level deeper, and we're trying to pixel march. So pixel. So I'm gonna like double label this section, right? So so we have these 2. So these are synonymous, right? So rather than coming up with like a really, really long name longer than this, we still want to keep some dashes, so that this is obviously a section start and this is obviously a section end from the complementary symmetries of these sections. But yeah, so this is the pixel marching, and we need to kind of use the exact same logic we used for the voxel marching, but we need to do it with pixels. The question now is, or at least the question I have is there some type of generic way we could handle this, right? Could we somehow... well, we can't really pass pointers, can we? We can't pass pointers in GLSL, and we can't have recursion in GLSL either, right? So if we can't pass pointers, then we can't pass pointers to data. And if we can't pass pointers to data, then I really don't see how we could... well, I mean, I guess just because we don't have pointers doesn't mean that we can't be clever and have like a giant texture or a giant array and use handles into that array and kind of pretend that that array is like mallocked memory and pass around indexes that are pointing to different places inside that array, right? We could do that, and that would still give us kind of a pointer type functional behavior. So let's not totally write off that, oh, we can't have pointers in GLSL. We can definitely, if we really need some type of pointer-like behavior, we can get that happening. So let's totally forget about that aspect, right? So in terms of some type of reusable function where we are going to figure out this ray marching stuff, how are we going to do that? So let's look at the epsilon x in our ray marching stuff. So our original oh, okay, I was a little confused here. I'm like, what's all these diagrams? This shouldn't be in our code. This should be offboard in the comments section. And no, this actually is in the comments section. So let's look at this code. So this code, can we write this code in a generic way? So XYZ RWN, and The answer is yes, with a but. We could write this code in a generic way. And so let me take this signature, because the signature is all we really need to realize that we can write it in a generic way. So I realize that from here we're like deriving the tile x and the tile y. That makes sense, but okay. The context of this function is that we are in the world space, right? And this xyz is within that world space. So how would we kind of write this in a more generic way? Well, I think we need some type of we need a v3 something like a I usually call it like a stack address. And how many levels deep do we want to go? Do we just want, if we just want voxels, then we just need one thing here, right? And this one thing will be the dex 2D of the voxel. Now, if we want to go 2 levels deep, we're gonna need an array that has the dex 2D of the voxel, and then the next thing it can store is the dex 2D of the pixel. Now, if we want something that comes after pixels, then we need 3, and so on and so on and so on. At whatever level of nesting we want to do, we have to pass the entire address, right? So it's like this address that's composed of these different indices, right? To accurately locate where we are, right? And then the next thing we need to do is we need to do v3, it would be like a stack, we could call it stack pointer, right? And this stack pointer points into here, right? And tells us which one to grab out. However, stack pointer is great, but I think the name will deceive us. Stack context. Okay? So stack context, and stack context is the stack pointer thing, but the reason we call it stack context is because if stack context is 0, then that means that we're inside of a voxel, right? So we use stack address 0, right? So if stack context is 0, then we do stack address 0 to access which voxel we're in, because stack address 0 means we're inside a voxel. Stack context 1 means we're inside a pixel, and stack context 2 means we're inside of whatever thing you want to call anything nested deeper than that. So my thought on that is, let's make a little comment here, and I think we can actually make this more generic, and that will also this is also going to help our efforts to, if we actually want some type of nested auto tiling, it's going to help with that effort as well. So let's just make a note here that stack pointer is equal to stack context, right? Just make a little note of that. And now the next thing is that I really don't like these kind of variables. I would rather have something short and like STK or STA, if we want to keep that kind of like stack, and then ADD, right? And then STA and context, right? Stack address, stack context, right? Just keep it simple. Remember that our abbreviations should be the first 3 letters of each word. So we could do something like STK, ADD, and STA, TK, CTX. But I think we should use the first 3 letters of the word. So with that in mind, let's do STK address. And let's say Wrong. Use first 3 letters of each word. Thus, star, and stack, and address, like that. Okay. And then we'll do the same thing. That is really kind of whatever. It's verbose, but let's just stick with it, right? So then stack context will use stk ctx stk ctx, and for this same thing, it's star con for the first 3 letters of that, right? So the idea is that we don't want to have to we don't want to have to remember what our variable names are, right? And so we're being really terse, and you could be like, oh my god, it's so terse, how are you going to remember all of these weird-ass variable names? And the answer to that is, well, we just use the first 3 letters of every word, and then we're good, right? We have such a consistent habit that even though it looks really weird, our habits are so consistent, we're really not memorizing that much, you know? So from an outsider's perspective, we look like some type of photographic memory genius, but in fact, no, we're just full of OCD is what we really are. So the next thing is we should probably take the inverse of these phrases. So add STK, and add STK. Wrong in 2 ways. Should be, right, I'm not even going to explain what's wrong now, because it's going to be too verbose. So, we're just going to say it's wrong in 2 ways, and we'll leave that at that, right? So then if it's CTX STK, or CTX STK, or CTX, and then STK, this is also wrong in 2 ways, so we'll take that, we'll paste that, and then we'll do STA and con for context, right? So the address and the context. And you know, the address is really like maybe a, maybe it would make more sense as stack array. But we already know it's an array type, right? So we're not going to get any extra information from that if we just call array. And when I say stack address, I mean that when I'm calling this a stack address, I don't mean that this is a collection of 3 addresses. I mean that all of the values together are creating a unique address, right? So if you had like something like, you know, so if home equals 1 and, well, actually, no, let's be a little bit generic. So, galaxy equals 1, planet equals 2, and continents, right? That's making a big assumption that all planets have continents, but let's just go with it. Planet, continent, and state, and, you know, city. Okay, so let's say we have that, right? So let's not go any further than that. Let's just say we have these kind of like these enums here, right? So let's just use some JavaScript because I'm a little bit more, well, no, maybe we should just stick to C style code and hope that I write it correctly. So if we want to have a stack address that's going to locate where we are in the galaxy all the way down to the city, our stack address would be, we're using int32s, so we're going to use a int32, and this is a type def, or a define, if you will, for a signed integer that's 32 bits. We're going to take that int32, and we'll say that stack address, and it has 5 elements in it, and it is set equal to And I32, I think we construct it like that. Let's, oh no, it's I32, and we're trying to use the proper GLSL code here, so, otherwise I'd just write it in JavaScript, and I'd be done already, but, I want to try to stick to one language here in this podcast, just so that I'm not, like, using syntax that people don't understand. So, I32 stack address has 5 slots in it. It's an array with 5 slots, and we're going to initialize it, right? So, so then we could say, enum value, Milky Way, and then we could say, enum value, Earth, and enum value state, or continent, sorry, continent, and enum value state, oh, hold on, we're not doing this right, enum value, should be like, I live in Ann Arbor, so we'll call that Ann Arbor, enum value should be, Michigan, sorry, not Michigan, continent should be, North America, or actually North America isn't a continent. Is it? No, it is. Jesus Christ, I do not know my geography. I'm not gonna claim to know certain things like the months of the year, and what day Thanksgiving, Christmas, and whatever other holiday is not Halloween. I really don't know what day they come on. Come on, whatever. Shouldn't all the holidays just happen on, like, the last day of the month? Wouldn't that just make it easy? February. Valentine's Day. Okay, make that the last day of the month. November. Oh, that's Thanksgiving. Okay, make that the last day of the month. Alright. Christmas. Okay, that's easy. Just make that the last day of the month. See, everything's simple now. Oh, except New Year's Eve and then Christmas would be on the same day, right? Something like that. Okay, so let's let's just look at where North America is really quick. North America. Make sure. I'm just gonna look at some Google Maps here. North America, Wikipedia. Let's look that up. Make sure I know it. North America is a continent entirely within. Okay, whatever they call it, a continent. So we're done there. It's a continent. Done. It looks like Canada, United States, and Mexico. Got it. Okay, done. So you might say, you're stupid because you don't know North America is a continent, and I say to you, what? What, am I a fucking sailor? How is that information relevant to my daily life? Right? Because knowledge needs to be something that you can act on, and if you can't really act on it, it's not really useful information. It's just trivia. Yes. Now, if you're a politician or some military strategist, then yeah, I mean, it's no longer trivia. But depending on your domain of expertise and what you do, different things may or may not be trivia. And as far as I'm concerned, North America being a continent, that is trivia. Tell me how that's useful to me. In a way that is actionable, that I will act on, right? Okay, so now that I'm done ranting and sound like a complete backwoods idiot, because I just said that, but let's just keep on coding. So this is an example of a stack address where this is like this is actually a key here, right? So this is a key, right? And what we mean to say here is that stack address, and we have this actually off by 1, don't we? So, okay, so the key for this stack address concept is that 0 is going to give us the galaxy, 1 gives us the planet, 2 gives us the continent, 3 gives us the state, and 4 gives us the city, right? And so down here, in this stack address here, where we're using it, if we want to create a stack address that identifies where I am in the galaxy, we're going to say, okay, well, the first part of that is Milky Way. So in the first array slot, we'll store the enum for Milky Way, because the first array slot is a index to address what galaxy we're in. Okay, the next array slot is for identifying the planet we're in. So we're going to put an enum value for the planet. And then the next one is for the continent. We're being very presumptuous, assuming that all planets have these continents, or have continents in general. So we'll put the enum for North America. Now, for the state, right, so now we're assuming that all planets have civilizations, so now, like, we really gotta check our privilege. And then we go down to, like, Ann Arbor, right, so Michigan, Ann Arbor, right, because the last thing here is to identify the city we're in, right? So that is the concept of a stack address, and we can use that concept to create kind of like a pointer type structure, but not really. It's more of a context, right? This stack address is more of a context. Well, the context is actually pointing to the specific where we are currently in the stack of addresses. So stack context, right? Stack context is going to have the values 0, 1, 2, 3, or 4. And that just tells us, are we currently in the galaxy? Are we currently in the planet? Are we currently in the continent, state, or city, right? And so where are we in relationship to the address, which also functions as instructions for locating the final destination, if that makes sense, right? Whew. Okay, and also this also kind of creates a, we've created this array, but we also we've kind of unwrapped a nesting structure into a one-dimensional structure here, right? Because if we say that the context is 2, then we know we're in the continent, but we also have access to the stack address, so we can traverse up and down this tree, right? So this may look like a list, but in reality, this is like a tree structure, right? So this I think is a very useful abstraction, and I have used this before, and I actually can show you where I've used this before. I've used it in like quad tree-like structures. So let me look at some of my demos really quick, JMIM demos, and show you something I worked on. I thought it was cool. I mean, I made it a few years ago in like OpenGL, I made it in like HTML canvas. So let's see if we can get that up and I can show you what I'm talking about. And then I think we're going to put this explanation into the comments so that we can kind of keep this as documentation for how we want this to progress. So, okay, there my demos page loaded up. So let's put that over there, and then I can show you what this is all about. Okay, so, you know, I've been working on some stuff. Let's boop, 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 boop. Where are you? What am I? I'm looking at something that uses the stack address. Oh, so this guy right here. So this, is basically a quad tree style structure. Well, actually, it is a quad tree. It's just visually represented as triangles, right? Because each triangle can be subdivided into 4 more triangles, right? You might think, oh, it's only subdivided into 3 triangles, but no, right? Because you got the little Triforce thing, but then you got a triangle in the middle as well. So this was just something where I designed it to allow me to like click and subdivide the triangles, and then mirror the pattern by mirror the pattern. So the pattern is not mirrored by just copying and pasting, but rather by I instantiate this object like multiple times, and I rotate the object, and then I just relay the same exact commands to all of the instantiated objects, and that's what gives us this mirroring effect. So this mirroring effect isn't like a copying and pasting of pixels, it's actually taking a command from one object and then replaying that command in one of the other objects. So if you look at this object that we see here, it is actually a hexagon, right? 1, 2, 3, 4, 5, 6. So I have six identical systems that have been instantiated, and then those systems have been rotated into different spaces, right? And then when I click down in this bottom triangle that makes up the bottom of this hexagon, when I click here, that signal is going to be relayed to the other triangular slices that make up this hexagonal canvas. But anyways, that's just a rant. But the point is that the way I store the nesting information of like what triangle we're in is a stack address, right? So you could do it like, if we want to explain this again. So remember that we can only be in a triangle can be subdivided into 4 shapes, right? So that means when we click the triangle, we can figure out if we are in the first subtriangle, the second subtriangle, the third subtriangle, or the fourth and final subtriangle. So if we do something like this, then we know that we are 1, 2, 3, 4, 5 levels of nesting deep. We pick the second triangle. Then when we're inside the second triangle, we pick the third triangle of that second triangle. Then when we're inside the third triangle, we pick the fourth triangle of that. And then when we're in the fourth triangle, we pick the fourth triangle of the fourth triangle. And then when we are in the fifth and final triangle, we pick the second triangle, right? So, because everything is off by 1 here because 0 is the first index, right? So this is the concept of like a stack address, right? So rather than creating some weird fucking data structure that has like nodes and whatnot and trying to link all those nodes together, no, it's a lot more simple than that. If your structure is very regular, that's all you need, right? You just need that. You don't need some fancy ass node structure, right? So we don't even have to worry about the fact that we don't have pointers, because we don't need like some fancy linked list kind of thing to create quad tree like structures. We can do it in that kind of manner, and that'll work perfectly fine. So that's my rant, and let's just finish what we were working on. So we have that, and did we even add the actual variable names, or did we just create the variables for all the things that were wrong? Because I may have done that. So if we do that, yeah, we created just the variables for everything that was completely wrong. So STA address. Let's make sure that we don't have a variable for that. Doesn't look like we do. And if we type it like that, we'll autocomplete it. So it's kind of like autocomplete, but you have to know exactly what you want in the first place. And that's just, so my style is kind of designed to prevent me from groping around blindly in my code and being like, ooh, what does this thing do? What does that thing do? No, I have to actually know what I want. And if I don't know what I want, I have to read the source code. So, is that some type of macho nerdist elitism? Yeah, I think it is. And does that make sense for me to be like that? Because it's not like I'm not a genius here. I don't have a photographic memory, so it's like, who am I to be some elite presumptuous bastard when I'm not a fucking genius. I just have a decent amount of creativity, man. So yeah, stack address, and then let's do the same thing for the stack context, right? And that's just, the stack context just tells us where we currently are in this hierarchy, right? So stack context, and then we'll do U plus the bonds hexa. do that. Okay, and then stack context, and stack context, right? So if we type it like that, we'll get answers, right? And the next thing we want to do is, well, what if we type it backwards, right? So if we do this backwards, and do we have the correct backwards? No, we don't. Okay, so if we do it backwards, we just say backwards and use, and then we say stack add. Okay, and then we want the same thing for this one. So if we accidentally type that backwards, consta, we'll do backwards, use stack context, right? And the reason for that is we can obviously see that the shared aspect of these two variables is the stack, right? And whenever possible, I want to always go in general to specific order. Sometimes what is general and what is specific depends on the context and the other variables that are grouped together. So sometimes I do have weird inconsistencies because once we stick to a certain variable name, even if it makes sense to swap these pieces, because general to specific has changed because of the context, even if that is true, we're going to grandfather in this variable name, right? Even if something else is general to specific in a different context. That's just the way I've decided to go with it. So what else do we need to do here? We should probably have a explanation of what that is. So what do these variables mean, right? And staAdd means stack address. Okay. And over here, same thing. We're going to document this as well. So we're going to do sta-con, and sta-con. And we actually have to have the dash for means. Otherwise, yeah, there we go. Okay. And this one means stack context. Stack context, right? Where you currently are in okay. Another thought I just remember is, so we have this like stack address thing, and we already decided that we do not want to call it stack array, right? So if we have if we find something like that, we want to be like, no, hell no, no, right? So is to vague use okay. And if we do it backwards and that, so if we do ARRSTA, ARRSTA, and ARRSTA like that, or, hold on, ARRSTA. If we do these, we're going to say backwards and vague. We're not even going to give an explanation. If we need an explanation of why that is backwards and vague, then we will go into the source code of our shortcuts and we'll find the answer there. 1, 2, 3, 4. Use staAdd. Okay. So what else is... what else needs kind of addressing here? And I think the next thing that kind of I think needs addressing is there's other ways to misspell okay, hold on. There's other ways to misspell what we have what we've done here. So So we've done the one with array, but we need to do the exact same thing, but we need to use the abbreviation STK, right? So STK AAR, and let's just make sure that's not anywhere else. Nope, okay. Just making sure. And let's just take it, and anywhere we see STA, we'll just paste the STK, right? STK, STK, and stack address. Yep. And vague and improper ABBRV. Vague and improper, improper abbreviation, that is. SDK, SDK, SDK. Backwards, vague, and improper, right? We can make a little note of improper, improper abbreviation, STK, right? We can make a note of what do we mean by improper, just so, you know, a few years from now, we'll know what the hell we meant by improper, right? Because that itself is vague as well. So now that we have that, I think we have, right, so this is, right, this is kind of like overkill, right? But this is kind of how I do my stuff. So, you know, I don't think you get, you don't get any revolutionary technology from somebody who does stuff the way that everybody else has always done it. Or at least I don't think you do. Now, am I saying I'm gonna make something revolutionary? Yeah, I don't know. I don't know. I would like to make something revolutionary, but, you know, I'm not gonna, you know, I'm not gonna, how do you say it? I'm not gonna be devastated if I never accomplish something like that in my life. I'm just gonna try to enjoy doing what I do, and, if something awesome eventually is created from the kind of weird stuff I'm doing, then that'll be awesome. Okay, you know, we could make a note here. We could go a little bit more overkill. We could say, date, section added date, and just do 2020 12/01. And that way we know kind of when this was added. And then we can do the same thing above, so we know, also we could make this a note. We could do above and below, right? That way we know without a doubt that what section we're talking about. Okay. So that is a lot of spewing, right? So let's take all of this. We're going to take all of this, and we're going to put this into our documentation as well. So we're going to go down into our documentation section, and we're going to say, stack address, details? I don't know. Stack, sure, why not? Or stack address workings. I don't know. Something that kind of tells us, like, I don't know, stack address instructional manual. I don't know what we want to call it. But let's just take all of this code here, or this pseudocode, because I think this pseudocode kind of helps identify kind of how we want to think about what we're doing. And, let's, you know, let's keep this comment, like, right up here. Whatever, we'll keep that oh, no, we won't. We are inside of a multi-line comment. If we do that, we're gonna blow everything up. We're gonna blow everything up if we do that. Let's just, do something like this, right? If we wanna glue that up to the top of the section, we can just do that, right? Fine, whatever. So this is stack address, this is stack context. So stack address and the stack context. And the reason why it's address first and then context is because context depends on stack address, right? Because you have to, before you can have this, you need to have this, because this is going to look inside of this, right? So that's another thing. When we think of ordering, we want to go from general to specific, and we also want to go in a logical dependency order, right? So that is the logical dependency order for that. So let's take this, and this is like get vox, use whatever, and we want to call it get I'm gonna call it I want to call it I'm gonna call it hyperpixel n. I don't know. So let's think about what we're gonna call this. We need some type of, if we're gonna have like different nesting structures in here, right, where we have a voxel, and then we have pixels inside that voxel, and that pixel has something else inside of it, and that thing has something else inside of it, and that thing has something else inside of it, right? And on and on and on like that. Hell no, I don't want some type of unique name for every single layer. In fact, we should cut that shit out right now, right? And we should think of it as a, I know there's the term hyper operation in mathematics, where multiplication is just hyper addition, and exponentiation is just hyper multiplication, and then you can take those hyper operations infinitely. You can infinitely compound them to create more hyper operations. I don't know exactly how that works. But the idea is that there's this weird compounding and levels of magnitude. That didn't make much sense. I did not explain that well. I'm sorry. So we're going to think about, right? We're trying to create some type of. It's not a get voxel function. It's not a get pixel function, it's a get some other type of more generic thing. And what is that called? And so I think I want to call it like a hyperpixel or a hypertile, but I already have something called a hypertile. Let's look up hypertile in my documentation and kind of see rendered results of a layer tile size combination. So that might be a bad idea to use the word hypertile, even though we kind of want to go with that analogy. So we could call it what are those nesting dolls? Do they have a specific name? Can we kind of name something after that? Nesting dolls. What are they called? Let's can we get on Wikipedia here? Nesting dolls, Wikipedia. So let's try to figure out some type of term that would make sense. Oh god, I cannot pronounce that. So I'm gonna have to look at this on YouTube, because I can't. Oh wait, there's a little thing. Let's try to listen to this.
Матрёшка. Матрёшка.
Matryoshka.
Матрёшка.
Matryoshka.
Матрёшка.
Matryoshka. Matryoshka.
Матрёшка.
Matryoshka.
Матрёшка.
Matryoshka.
Матрёшка.
Matryoshka.
Матрёшка.
Okay. I'm not gonna remember that, even if I can get the pronunciation right. Thing is that if even if we abbreviate that, then we have MAT, which could be kind of like a matrix, so that would be bad. Let's read up on what a voxel is. Voxel Wikipedia. Maybe there's some type of information that can kind of tell us. In 3D computer graphics, a voxel represents a value on a regular grid in three-dimensional space with pixels in a 2D bitmap. Voxels themselves do not typically have their position, i.e. coordinates, explicitly encoded in their values. Instead, rendering systems infer the position of a voxel based on its position relative to other voxels, i.e. its position in the data structure that makes up a single volumetric image. Okay, so we're not doing voxels by the book, because we're thinking of voxels as three-dimensional tiles. So we might want to nix that part of the definition. In contrast to pixels and voxels, polygons, blah blah blah. I don't care. I understand the difference. Yeah, voxel originated from the word pixel, with vo representing volume. Okay, vo is for volume. Okay, we're gonna call it von. We're gonna call it von for volume. Instead of element, it's going to be volume n, as in n levels deep. Yep, I'm good with that. That's what we're calling it. Okay, so we're going to call it get von. Get von, use xy use xyz rwn and STA address and STA con. Now the other thing is, why not just name it address and con, right, and shorten this variable name? And I could do that, but the problem with that is we want the code to be as unambiguous as possible. And you might say, what do you mean unambiguous? I mean, look at this shit right here. Like, look at how terse that is, right? But by unambiguous, I mean that when I look at this code, I know, oh, XYZ's right there, RWN's right there, the STA address is right there, and then this STA con, that's right there, right? So we know without a doubt what this function does. So all you're doing with when you're programming is you're just transforming data. So is this data-oriented design, or is this just me being batshit crazy? I don't know, but so far I think I really like this style I've come up with. I don't know. I don't think it's unique. I'm sure somebody else has already thought this up. But let's just roll with it and keep on doing what we're doing. So if we highlight this, we can double check, make sure that everything is there, right? The stack address and the stack con, right? So we need to know what von is. So von is volume n as in n number of nesting. Okay, n n equals number is nesting level. Right, so chose name based on origins of the word voxel from Wikipedia. So this is so von is going to be a word for a voxel that may exist at any different levels of nesting, right? So we'll say a von 0 would be your traditional voxel. We'll say a von 1 is a pixel within a voxel, right? Because we're doing the 3D tile map analogy. And then von 3 or von 2 is something within inside a von 1. A von 3 is something within a von 2, right? And so then we can just think about it as these sequential nestings, and we don't have to like come up with weird names. We don't got to think about like quarks, gluons, protons, neutrons, electrons, string theory. I don't know. You know, the idea like where matter every time we try to get like a microscope and figure out what's in there, and we get an electron microscope and we look really deep, and you know, we just find more and more particles, right? We think these particles are undivisible, but we look deeper and deeper and deeper, and we just find more things. Then we gotta give them more names, and you know, at some time you gotta stop using names and just start like numbering that shit. So let's so we're going to try to stop numbering or stop naming after pixel, right? So we got the voxels, and then inside of the voxels we have pixels, and after that it's just numbers, right? We're now as far as how deep we want to go. That part has to be hard-coded, right? So this stack address, how many layers deep do we want to go? Do we just want to have, how many layers is necessary to get something interesting, right? Because I believe that at some level, the extra layers are just going to kind of create a just noise. It'll just become noise. So my thought is, let's think about it. So everything is like a different order of magnitude. I feel like you kind of at least need these 3 levels. You need like a large block size, some coarse details on that block, and then some fine details, right? So 3 levels of detail, I think, is your minimum for getting something, getting something quality. I don't know. 3 establishes a pattern. You know, think about parallax. If you're trying to parallax, 1 scrolling background is good. 2 scrolling backgrounds, I think, is the minimum to have any type of parallax, right? I guess technically 1 scrolling background is still parallax, but I think you would need at least 2 scrolling backgrounds to make it look good. So I guess, see, that's like 3 right there. That could be just confirmation bias, but you know, maybe I just learned in art school that you need a minimum of 3 things to establish a pattern, and therefore 3 should be the minimum here as well, because I think that like everything in art and in kind of like lines up. But maybe I'm just crazy. Okay, so with that, we're inside of a comment area, so you might be like, well, we're inside a comment area, why are we writing this? And this is just so we can think about it, right? So maybe 1, 2, 3, 4, 5, right? So that's 5, so maybe we want to like do that, right? And maybe we want to like have this key, like maybe we want to like write the key kind of like inside this or actually maybe we want to, actually the key would actually make more sense over here. So because we have this kind of key, and example for this. So this would be a von 0. This would be von 001. This would be von 002. And right, so von 003. So instead of like being galaxy, planet, continent, state, city, you can keep on going deeper and deeper. Screw that. Let's just serialize it and give them just serial numbers, right? This galaxy, no, you're not a galaxy, you're a Von 0. Planet, you're not a planet, you're a Von 1. Continent, no, you're not a continent, you're a Von 2, right? State, no, you're not a state, you're just a Von 3. City, you're not a city, screw that, I don't want to have to memorize that word, you're just a Von 4, right? So now I just have to remember the word Von and just think about the nesting level, and we can forget about these kind of like over abstractions, right? We really don't care about this, right? Maybe later we'll care about the use case, but the most important part is just kind of the data, right? So, with that, we can, we got the stack address, that variable name matches here. So, is this all, what is this Von object, right? So, so Von, all capital, what is inside of Von? So, traverse, nested data structure, using stack address and sta con. Let's I'd like that. Using and return generic Von struct that could represent one voxel, 2 pixel, 3 something nested deeper, 4 nested even deeper, and deeper, etc. Okay, so here we're going to use the nested data structure. We're going to traverse the nested data structure using this stack address in the stack context and return a generic Von struct that could represent a voxel, Von 000, a pixel, Von 001, something nested deeper, something, etc., etc., Von, right? So this is just what we're going to call them if we know the nesting level. Otherwise, we'll just generically call it a Von, right? So, return Von, right? Okay, so that's kind of like what we want that kind of logic to look like. And we're just going to keep this in this stack address working section. So we're actually going to just keep that code because it's a good like design document for explaining how we're trying to do this, right? Let's see. So almost 3 hours. What else? So we've kind of gone off the rails a bit, and we're thinking a little bit way in the future, but by thinking ahead a little bit, we'll hopefully not put ourselves in any design situations where we can't work our way out of them. So so what do we need when we're what do we need to get out of what should be in one of these structs? What should be in this struct here? This Von struct, right? What should be in here? And I think that what there should be is there should be a should call it a Von Dex. Actually, no, a Von D3D, because no matter what we do, this is all gonna be 3D for our purposes. So this Von object is going to be 3D. So so this could be the tile D3D 3D pix D3D etc, right? So this D3D value is an abstraction of these values that we've kind of already pulled out of code, but we're just abstracting it so that let's try to. We're just abstracting it so that we can hopefully make this a little bit more generic, right? So, the next thing is, what about the data sets for these different things, right? Like, how are we going to manage that? And I think that one way is we got to take a larger data set, and we have to not only subdivide it into a three-dimensional space, but then we also have to subdivide that three-dimensional space into other three-dimensional spaces. And so we have to create kind of a way to partition a 1D array that gives us X, Y, Z, and then a branching structure as well. And I actually know how I'm going to accomplish that already, but I need to think that out on paper right now and think about what could be the application. How are we going to do that on paper? Because actually in this Von object, I think this is all we really need, right? And then we can, as long as we have this, and then I guess we technically need the, yeah, I mean, as long as as long as the other information could all be global, this is actually all we need. So I don't even think we need any other information in this Von struct, but it could be good just to put this in a container just because this is a half-baked idea, and it could definitely we could definitely be not considering some other things. But I think this is the main piece of information we need. We just need this thing, right? Which could be this or that, right? So let's think about, I want to think about how the data structure is going to look for this. And I'm going to write that down really quick. So how to create okay, so I have some thoughts about how I want to go about that, but let's take this stack address workings and let's put that wherever the hell that should go. So we need to somewhere we had the word generic. Oh, that's the only place we're using generic. So let's go into like our little control F section where we're kind of like keeping like little keywords for things. And let's say generic Uh, and we could do Vaughn. Or not Vaughn, but what did we put in there? We had like a whole phrase, right? So if you're looking for generic, you could try stack address workings. So that's just entry 1 for generic, and then generic 002. And I'm not sure where that other thing is, but we have another function we need to look at. Let's check out our breakpoints. We might actually have the breakpoint. So in here, we're going to get the pixels 000, use XYZ artifact. Yeah, so this is this right, so these two things could be collapsed into a stack address, right? We could yeah, we could definitely throw this into like a stack address. And now the thing is that it might be beneficial, even though we could throw this into a stack address and kind of like recursively solve. Maybe it would be beneficial for us to actually, no, it'd be more beneficial for us to solve it with a stack address type pattern, so that we can understand how that abstraction works. But maybe so okay, so this right here, we actually want to say we could say that this really could make and I don't remember what it's called. I'm a little bit tired here. So this could make use of so this could let's look for it again. Whatever. Could make use of now that's not the way we're doing it right now, but it could make use of that, right? So I notice we have a lack of indentation here, right? We have this SDF march into Voxel, and we have not indented here like we usually do, right? And then this, what the heck is this? We have no label here. Let's clean this up again. This is, what is this? This is integer map uint32 to color 4D. That's what this is. So let's clean this up a bit. And okay, and then we can okay, so that is actually indented properly because we have the defines at the same level as the labels. So that's good, but this is wrong. This should actually be indented one more level. So, Is that just going to be a problem for us? I don't know. Let's just do it. Let's worry about the consequences later, I guess. So now we've already screwed up everything. But, you know, I think it's good to be tidy here. So let's just take some time to do some housekeeping. Because I can't really think straight to do anything useful right now. And so I've kind of like thought some things through, and that's going to be helpful. But as far as doing anything super useful, not right now. Not right now. So... Okay. Okay, so... if we look at this, we had a little to-do there. So now that's leaking off the edge. That's all like, great. So that's great. We're gonna have to fix that. But let's think about. So I'm thinking that this could be. This right here could be a stack address, right? And before we even get this deep, if that's like really how we want to do this, we should probably think about taking the current ray marching loop and abstracting it to use that stack address type thing, and that could be a big overhaul. But the sooner we abstract it to that level, the sooner it's going to be easy to go further, right? So, so let's think about doing that next. Is just doing a refactor and trying to get which refactors aren't fun, but trying to get the same functionality but refactoring it to implement a stack address, right? So instead of get pix and get voxel, we're gonna have just get von and then the stack address stuff. So let's yeah, I think that might be the way to go there. So let's control A this, and let's see. Let's look for the word generic. Get pix. Dot dot dot. So get pix 00, that could use it. So in our notes, this get pix could use it. So just a note for that. So okay, let's take everything and let's paste it into Shader Toy, and let's see if we can get this kind of working here. I would assume we had made a mistake. And that is a syntax error within the comment sections. That is a no-no. So did we put a comment character somewhere in this? And yes, we did. We did it right here. So let's not do that. So, von d3d equals, we can put that in brackets like that. Okay, and we could also line it up like that if we wanted to. And is there any other multi-line comment characters in here? No, it doesn't look like it is, so let's take that. And, I mean... Okay, so we're good, because we didn't really add any other functionality. We just kind of, like, added some commentary and some thoughts on the design. So now the next thing I want to do is I want to think about if this is really where I want to go with this. How would I go about creating the correct data structure for that? So I'm gonna take a break, and I think I'm done for now. So this is just an update. Let's save what we've done so far. So we have all these notes. Let's save it. So if we just hit save, okay, we've saved that. And then if we take all of our code, we're going to take all of our code that we have, we're going to copy it, and we're going to go to pastebin, www.pastebin, actually no, we'll go to the tiny URL, so www.tinyurl.com/sdf-016, because that's the file we're in, and we'll just edit it. And we'll paste that in there. And then we'll save the changes. So we got like a pretty cool idea of like where we want to go with this, but now we need to think about the reasonable steps to incrementally work up there, because if we try to like take on this massive thing all at once, we're just gonna end up with horrible problems. So let's think about how we can incrementally add and get feedback, right? We want to add a little bit of code, get some feedback, add a little bit of code, get some feedback, and think about how that's going to be done. Because if we ignore being able to get feedback, and we don't think about we got to think about what we want, how we're going to build up to it, and we also need to consider how we're going to get feedback as we build up to it, right? So there's a lot of considerations. It's not just go from point A to B. It's there's a certain path you really need to take, or otherwise this could end horribly. So okay, so that's it. I'm gonna draw some diagrams and think about how the data would be stored in a structure, or how the one-dimensional array of data would map to this kind of like three-dimensional nesting structure. So yeah, I'm gonna stop recording.